All right, let's take a look at building materials using Keyshot's material graph. Now, the material graph can be intimidating to someone who hasn't used it before because it's what's called a node-based workflow. However, node-based workflows are really efficient and they're good for saving a lot of time. And if you're anything like me, being more of a visual learner, a node-based workspace is actually easier to learn, I believe. So the way we get to the material graph is we click on the button right underneath the name of the material that we're editing. So I've turned back on the table we've been working on, and if I go into its material graph, we will see that it has a few boxes connected by blue strings or connectors. Now these boxes are what we call nodes, and these blue connectors are just called blue connectors. The white dots on either side of the node are called sockets. And an inbound socket is on the left side of a node and the outbound socket is on the right side of the node. Now the node that's currently selected is outlined in orange, and this one is called the root node. It's the furthest to the right. So the root node is always on the furthest to the right. If I disconnect the plastic material node from the root node, we will see that underneath that plastic, or without it, we have no material visible. We have just a network of triangles. This is called our geometry. So the root node always represents the geometry itself. Now, when we take a material such as a plastic and we connect its outbound socket to the inbound socket of the root node in the surface, we apply this plastic material to the root node's surface. And therefore we can see this plastic on the surface of the root node, which is the geometry. Now we also have a couple of textures that are plugged into our plastic material. If we disable them, which is the same thing as disconnecting them pretty much, we will see that we have just a plastic material void of any sort of textures. But the plastic's red and our plastic node shows a white thumbnail. I know that's confusing, but the plastic, or rather the material nodes, don't necessarily update. The thumbnails don't update in real time. In fact, just the root node and its Keyshot material ball updates. If I double click on the plastic or any of these nodes, I will see its properties on the right-hand side of our screen. So it's actually the same data that we would see in the project panel on the right side of Keyshot's interface. It's just contained within the material graph, and it's just going to show the material properties. So again, our plastic is orange. It's outlined in orange. That means that what we're seeing on the right-hand side pertains to this actively selected node. And we see that, yes, it does have a texture applied to it, but it's disabled. The texture is turned off. So when we turn it off, we see whatever color was last applied to that plastic material. So while the texture is disabled, if I set this to just a plain old black, then it becomes a black plastic. Now, if I go to the texture subtab, I can turn on that diffuse texture, or I could turn on just the bump texture on its own, and I could see the effects of that. So what's nice is we can use these nodes to build our materials instead of relying on layers and layers of menu items in the other Keyshot workspace. As our material gets more complex and as we want to do more advanced things with it, these nodes become a lot more flexible because we can connect them to more properties than we could without the material graph. Now to back out, I will say we have across the top of this workspace a ribbon with a few buttons that you'll press, but mostly you won't be working on here too much. This is the name of the material we're working on now, Satin Red Plastic 1. So if we ever want to name it and save it, we would do that right here. We'll edit by adding different nodes. We can either right click in the workspace and access any of the nodes from these lists here, or we could drag items from our library into the material graph workspace. And lastly, if we're editing an item or a node in the middle of the workspace, just double click on it and its properties will show up on the right-hand side, and then we can edit them from there. So if I want to enable the texture that's in our diffuse channel of our plastic, and if I click Move Texture, we can see as I move it in the real-time view, any of our mapping should update on the right-hand side in the material graph. So you can see as I move it around, all of our mapping settings are updating in real time. All right, so this is how you build materials using the material graph, as well as a very low level of how the material graph works. You basically right-click, you grab a node, say metal, And if I want to turn this piece into metal, I just connect it into the surface of the root node. And now this plastic and these textures get completely ignored. We're just using the metal because it's connected to the root node. Everything else outside of it is not connected. Therefore, all this is ignored right now. So right now we just have a metal on top of our root node. And if at any point we want to go back into here, we can make it plastic or we can make it metal. And if at any point I want to connect one of these textures to the metal, I can plug it into bump. There we go. Now the reason it didn't work for color is because metal is in measured mode right now. If I go to color, then it will inherit its color from this texture. And we can even plug it into bump. So this shows that we can grab two connectors, or really any number of connectors, out of an outbound socket. We just can't have multiple connectors going to an inbound socket. And this plastic right here is being ignored. Same with this texture here. They are not doing anything. Even though they're connected, they're not having an effect on the appearance of this because this is in no way connected to our root node. So I can delete this, and now we're just with the metal. All right, so we're gonna take a break, but in the next video, I'm going to dive deep into procedural textures and why they're so much cooler and better than your basic, boring, old image-based texture like we have on screen.